Hello students, welcome to Examora, your smart way to prepare for the exams. Welcome back to today's session. In today's class, we are going to learn a very interesting type of question from number play. Many students feel confused when they see these questions because they don't know where to start. But don't worry, after this lesson, you will be able to solve them confidently. Before solve these questions, let us understand the rules and correct thinking processes. Once you understand the method, every question becomes very easy. So, let's move to our session. Use the numbers in the boxes below, applying both addition and subtraction to get the required number. So, before doing this question, we have to understand some rules related to this. Rule number 1. Use only the numbers given in the boxes. Rule number 2. Use only the mathematical operations mentioned in the question. The operations may be addition, subtraction, multiplication or division. For this question, we have to use only addition and subtraction. Rule number 3. You don't have to use all numbers, but each number can be used only once. Rule number 4. First, choose the number that is closest to the required number. This helps you to reach the answer more easily. Rule number 5. Compare your result with the required number. If your result is less than the required number, use a suitable operations here add to increase it. If your result is more than the required number, use a suitable operation here subtract to decrease it. Here you can see 6 boxes. Each boxes contain numbers. So our task is to use only these numbers to make the required number. But there is one important condition: we can use addition and subtraction only here. Here is the first question. They already given to us as an example. The target number is 40,700. Let us see how they followed the rule. So as per the rule, we can take 40,000, which is nearest to the greatest number to our question. So after that, they applied subtraction here. Subtract 800. That brings us to 39,200. Applied addition. Addition of 1,500. So calculating all this number, we get the answer 40,700. Clear? Move to the second question. So as per the rule, we can take the number 40,000 also here, because it is nearest to the greatest single number available in our box. So, 40,000. Then we can take 12,000. So the answer is 52,000. Our target number is 59,000. So from the box, we can again add 70,000 from this box. So adding 70,000, we get the answer 52,000 plus 7,000. We get 59,000. Clear? So this is very easy. Just use your logic to finding the answers. Move to the next question, 17,500. So in this question, the nearest number to our target number is 12,000. So first we can take 12,000. After 12,000, we can add the next number, that is 7,000. So 12,000 plus 7,000. We can write like this, 12,000 plus 7,000. The answer is 17,500. So we can subtract 1,500. Here 1,500 is here, so we can subtract 1,500. So after that we get the answer 17,500. Clear? Next question, 21,400. This one you can do it as yourself. So move to the next one. Make a collage sequence starting with question number A, 5. So, before starting this question, we have to understand what a collage sequence is. A collage sequence is a list of numbers made by the following two simple math rules over and over again, starting with any odd numbers. Two rules are there. If the number is even, cut it in half, that is divided by 2. If the number is odd, multiply it by 3 and add 1. So in this question, 5, first we can check the number if it is even or odd. So here 5 is an odd number. Since it is an odd number, we can do the rule by using 5, multiply it by 3 and add 1. So in calculation, first step we can do like this. 3 into 5 plus 1. The answer is 16. So 16 is an even number. So we can do division by 2. So 16 divided by 2, we get the answer 8. Again, 8 is an even number. So divide by 2, we get the answer 4. Again, 4 is an even number. So half of that is 2. So 2 was an even number. So divide by 2, that is 1. So after reaching the number 1, the sequence will stop. So we get the sequence 16, 8, 4, 2, 1. We can write like this. 5 is the starting number, then 16, then 8, then 4, 2, and finally reached 1. Clear? So move to our second question, 10. So for this question, the number 10 is an even number. So we can do the step starting by divided it by 2. So the half of 10 is 5. So here we can do like this. 10 divided by 2, that is 5. 5 is an odd number. So we can multiply it by 3 and after that add 1. We get the answer 16. So 16 is an even number, so divide by 2, we get answer 8. And 8 is an even number. Also, we can do by divide by 2. Answer 4, again is an even number, so divide by 2, its answer is 2. Again 2 is an even number, 2 divided by 2, that is 1. So, we erased, we got the result. So, the steps are 10, then 5, 16, 8, 4, 2, and 1. So how many steps are there? We cannot count the starting number 10. Count from 5, the next step. So 1, 2, 3, 4, 5, 6. So 6 steps are there. Okay, clear? Next question, create a collage sequence starting with 75. You can do this yourself. It's a practice question. Next question, find the missing terms in the following collage sequences. So here, related to collage sequences, some questions are there and some parts are missing. We have to find out. But related to the previous number, whether it is even or odd. So let's take the first number 11, 34, 17. 17 is an odd number. So what to do? We can multiply 17 into 3, and plus 1. So 17 into 3, after that plus 1, we get the answer 52. So here we can write the answer 52. After that 26, 13, again an odd number. So we can write 13 into 3 plus 1. 13 into 3 plus 1, the answer is 40. So here we can write 40. So 40 is an even number. So half of 14, that is 20. Clear? So next one, 7-11. So 7 is an odd number. So what we can do? 7 into 3 plus 1. 7 into 3 plus 1. The answer is 22. So we can write here 22. 22 is an even number, so half of even 22 is 11. Next, 11 is an odd number, so we can again do 11 into 3 plus 1. 11 into 3 plus 1, the answer is 34. So 34 is an even number, so half of 34 is 17. Next, missing part 5. 5 is an odd number, so we can write 5 into 3 plus 1. 5 into 3 plus 1, that is 16. 16 is an even number, so divide by 2, that is 8. Clear? This is very easy. Question number 3, 25 dash. So 25 is an odd number, so 25 into 3 plus 1. The answer is 76. So we can write here 76. The half of 76 is 38. Again 19. 19 is an odd number, so 19 into 3 plus 1. 19 into 3 plus 1, that is 58. 58 is an even number, that's a half of 58. 58 divided by 2, that is 29. Again, 29 is an odd number, so we can do 29 into 3 plus 1. 29 into 3 plus 1, that is 88. 88 is an even number, so half of 88 is 44. Clear? The last question, you can do it as yourself. Okay. So let's move to the next question. Is it true that all Collat's weekends end with 1? So, according to Collat's conjecture, every positive whole number is believed to eventually reach 1. So here, answer is yes. So we can write yes. According to Collat's conjecture, every positive whole number is believed to eventually reach 1. Next question, write 4 different 3-digit number whose digit sum is 16. So here to find a 3-digit number whose digit sum is 16, we need to choose 3 single-digit numbers that added up to exactly 16 when placed together. So we can write the numbers 178. 178. 1 plus 7 plus 8, that is 16. 268. You can write any number according to your choice, but the condition is that whose digit sum is 16. Then 376 and 556. Okay? All these numbers, the digit sum is 16. Clear? So today we covered 3 main concepts. We looked at arranging numbers together to form a particular digit. We mastered Collat's sequence and practiced finding specific digit sums. So that's all for today. Practice well and cover all practice problems. If there is any doubt, please feel free to message. If you need any free PDF notes and all, please mention it in comments or Gmail me. We will come up with the next video soon. Till then, bye.